Hi everyone. In this video we are going to see the problem that is realization of D flip-flop using SR flip-flop. That means the thing we have to implement the D using SR, that is SR flip-flop, the input should be D. So the given flip-flop, step 1, the given flip-flop is SR. Draw the characteristics table of D flip-flop and excitation table of SR flip-flop. The characteristic table, that is Qn, D and Qn plus 1, that is present state, input and then Qn plus 1. Excitation table for SR flip-flop, that should be written when compared with the present state and next state of characteristics table represented in D flip-flop. 0, 0, that is 0x, that is Qn 0, Qn plus 1 0, so that when we compared this with the excitation table of SR flip-flop, that is output of SR should be written from the excitation table of SR flip-flop. 0, 1, that is taken from the characteristics table, that corresponding output for the excitation table of SR flip-flop is 1, 0. Likewise, we have to compare this to flip-flops characteristics table and excitation table, and we are writing these 0, 1 and toggle condition, that is X. And step 3, we have to do the K-map for the excitation table of SR flip-flop, and the input should be considered as Qn and D. So the K-map should be written as 0, 1, 0x. Similarly for R. So the number of pairs is 1. So S is equal to D, R is equal to D bar. So we'll draw the circuit diagram. That is SR flip-flop. S, the output for S is D and the output for R is D bar. So we are using one NOT gate from D, and it is complement to the R input. So it is R is equal to D bar. This is a circuit diagram for realization of D flip-flop using SR flip-flop. And then next example, that is next problem, similar to the previous one, we will see the realization of SR flip-flop using JK flip-flop. Here we have to draw the characteristics table of JK and excitation table of SR flip-flop. What we have done in the previous problem, similar to that, we have to write the excitation table. The excitation table should be written by comparing the inputs from the characteristics table of JK flip-flop, Qn and Qn plus 1. So the conditions are 0, 1, 0, 0. Likewise, we have to write. So first we'll see the condition 0, 0 means 0x. Again it is 0, 0, 0x, 0, 1, 1, 0, 0, 1, 1, 0. We don't bother about the thing that is J and K. We have to look into the thing is 0, 0. That is Qn and Qn plus 1. We have to, similarly, we have to do the K-map for S and R by considering the inputs Qn, J and K. That Qn, J and K should be in the binary order 0 to 7, so that we can draw the 3 variable K-map for S and R. By drawing this K-map, we have to compare we have to draw the number of pairs. For S it has 1 and 1, and also similarly for R it is also 1 and 1. So write the K-map output equation. S is equal to Qn bar J and R is equal to Qn K. Here you first draw the S and R, that is simple block for S and R with clock. First one, the output for S is Qn bar and J. So we will get the output as Q and Q bar, that is Q is the output and it is a complement, we will get it from the flip-flop. So we will take Q bar, that should be ANDed with J. The input should be J and K. So J and Q bar, Qn bar will be ANDed, that is AND gate, we should draw the AND gate and it should be given to the yes. Similarly for OR, Qn and K. So the output is Q we will take the another input from Q and the another input from J, and it should be ANDed and it given to the OR. This is the realization of flip-flops. Like this we can perform any flip-flop to any flip-flop. That is, we are having 4 flip-flops, we can done this realization for all the flip-flops. Thank you.